Hello everyone, we are going to see how to solve this summation. It says evaluate the summation of 3 the power of k plus 2 the power of k the whole the power of 6 the power of k and square it. The whole summation is going to be squared. First of all, we need to simplify the one which is found in the bracket. How to simplify? We can write it 3 the power of k over 6 the power of k plus 2 the power of k over 6 the power of k. That is the first step. We can do it. Then the whole the power of k will not be forgotten. Then these two fractions, both of them, they do have the same exponent, k. So we can write it as 3 over 6 the whole the power of k plus 2 over 6 the whole the power of k. We are trying to simplify. Then the whole square still remains. Then we can simplify this one. It's going to be 1 over 2. 1 over 2 the power of k plus 1 over 3 the power of k, the whole square. That is the next step. And then remember a plus b the whole square rule. A plus b the whole square means it is the same as a square plus 2ab plus b square. Applying this rule here, it will be when you square 1 over 2, the 1 over 2 the power of k means it's just 1 over 4. 1 over 4 the whole the power of k plus 2 times when you multiply the 2, okay, because it says 2ab. 2ab means we will multiply the 2, but they do have the same exponent, so the base will be multiplied. It's going to be 1 over 6. 1 over 6 the power of k plus again 1 over 3 the power of k will be squared. It's going to be 1 over 9. 1 over 9 the power of k. We squared it. And then the next step, let us bring it in the new page, and then let us see how does it looks. Now we will bring the whole summation and we will write what we have. Therefore, it's going to be the summation 1 over 4 the power of k plus 2 times 1 over 6 the power of k plus 1 over 9 the whole the power of k. We can give this summation for each of the addend, for each of them, and then the two constant can be taken out of the summation. Let us see how does it. So here it is. We can give the summation for each of them because it is plus. We can separate them. In one of the rule of addition of summation, we can do separately. Therefore, the two constant is taken out here. The two constant is taken out, and then finally it will be multiplied. And then at this point, we need to see this is geometric sequence. The G1 and the common ratio is 1 over 4, the one which is found in the bracket, because 1 over 4 the power of k. 1 over 4 it's less than 1. So we can apply geometric series formula, that is G1 over 1 minus R. For each of them, we can apply this formula and we can operate it. But because for all of them here, the G1 and the R is 1 over 4. Here, the G1 and the R is 1 over 6. In the last one, the G1 and the R is 1 over 9. So all of them are, since they are infinite series, as you see here, all of them are infinite series because we are asked the sum at infinity, each of them. K starts from 1 until infinity. So there we can apply the infinite series formula, that is G1 over 1 minus R. So, but for all of them, the G1 is 1 over 4 here. So 1 over 4 the whole over 1 minus 1 over 4. And the second also, the G1 is 1 over 6. So 1 over 6 over 1 minus 1 over 6. The common ratio also it's 1 over 6. You can check because this means 1 over 4 plus 1 over 4 square plus 1 over 4 cube. It continues in that manner. So it is summation of infinite series. The third one also the same manner. So we do have 1 over 4 the whole over 1 minus 1 over 4 plus 2 times 1 over 6 over 1 minus 1 over 6 plus 1 over 9 the whole over 1 minus 1 over 9. We can complete this sum. And how does it look? Let us go to the next page and let us see it. After we subtract the denominators, after subtracting the denominators for each of them, we will flip and multiply with the numerator. So it looks 1 over 4 times 4 over 3. It's flipped the second one, the denominator here, plus 2 times 1 over 6 times 6 over 5 plus 1 over 9 times 9 over 8. After this, that is simple simplification. We can simplify this one 4 by 4, then 1 left. 1 over 3 will be left here. It's going to be 1 over 3 here plus, here 6 will be cancelled with 6 and 2 over 5 left, plus here 9 by 9 cancel, it's going to be 1 over 8. So we can add this fraction, and the final answer, it's going to be 103 the whole over 103. So we need to see step by step process. What do we do here? The first thing, we try to like separate. We try to simplify the whole bracket. We took it here, as you see, and then we give the common denominator for each of them. So 3 the power of k over 6 the power of k plus 2 the power of k over 6 the power of k, the whole square comes. And then, since they do have the same exponent, we write 3 over 6 the whole the power of k plus 2 over 6 the whole the power of k, but still the square will remain there. And then when you simplify the one which is found in the bracket here, by 3 1 this by 3 2, which is going to be 1 over 2 the whole the power of k plus, the same manner for the second bracket, by 2 1 this by 2 3, it's going to be 1 over 3 the whole the power of k, the whole square. Then it's going to be, we can square. Then we have here binomial expansion. We have two terms, sum of two terms, a plus b the whole square means it's a square plus 2ab plus b square. We applied that rule. Then when you square 1 over 2 the whole the power of k, it's going to be 1 over 4 the whole the power of k. Or you can write it 1 over 2 the whole the power of 2k, but the 2 will be a square of 1 over 2, so it will be 1 over 4 the power of k, plus 2 times the product of the 2. When you multiply the 2, they do have the same exponent here, so we can multiply the base. 1 over 2 times 1 over 3, so it becomes 1 over 6, plus again 1 over 3 the whole the power of k. When we square it, it's going to be 1 over 9 the whole the power of k. Then what happened? Next one, we brought it together in the summation. So this is it. The next step, what do? We give the summation for each of them. So the summation of 1 over 4 the whole the power of k plus 2 times, because 2 is constant here, it can be taken out of the summation. Then the summation 1 over 6 the whole the power of k, plus again the summation 1 over 9 the whole the power of k. Each of them k start from 1 to infinity. Done. And the next step, we have seen each of them are geometric sequence. If you see the bracket, the one which is found in the bracket, if it is less than 1, it's a geometric sequence, and the g1 and the common ratio will be the same itself. So we can apply g1 over 1 minus r. So the g1 is itself, and the common ratio also itself, because here the number which is 1 over 4 is less than 1. If the common ratio is between -1 and 1, we can apply geometric sequence formula. So we did that one. In the next step, we simplified, and finally the answer became 103. So the question is, it looks like somehow longer process, but even if it is challenging, it will be done in this manner. Thank you for watching.